Good morning, the learners at home and all viewers. This week we're going to still look at the number bases. We are proceeding further this time around on operations with binary numbers. Based on the content of what we need to cover. Today we're going to look at the A aspect, which has to do with addition. And we are considering majorly binary numbers, that is numbers to base 2. In our first example on the board, we have 111,111 base 2. Then we have here 101,010 to base 2. And we have 10,001 to base 2. Now, one major thing on the addition, as usual, you must make sure if there are figures with units, the unit must be the same. If the units are not the same, you can add. If you add, you know your answer is going to be completely wrong. So if you have base 2, and here we have base 5, and here, for instance, we have another base 5, you can add them. You must convert them to the same base before you actually do the addition. So here is binary, and binary is all in base 2. So you can go ahead and just add the figure given. So add, we have this here, we have this here, and we have this one here. Now, the process of adding, when we have decimal number, which is the denary base 10, when you have up to 9 on the units, the next addition of 1 to it makes it 10. So it shifts to the next digit. But here, because it's base 2, no number goes beyond 2. And once the number gets to 2, it becomes a figure to carry to the next digit. If it goes to 3, it drops 1 and carry 1 to the next digit. It becomes 4. It drops 0 because we have 2 2s in 4. So that's how the procedure is in addition. Therefore, let's quickly solve this. We have 1 plus 0, 1 plus 1, 2. And 2 is to base 2, so it's 0. What we do? We carry 1 forward to the next digit. 1 plus 1, 2 plus 1, 3 plus 0, 3. Here we have 2s. We have 1 out of 3. So we drop the 1 left. We carry that other 1 to the next digit. 1 plus 1 making 2. 2 plus 0 will give us 2. So we drop 0 and carry the 1 to the next digits. And here we have 1 plus 1 making 3 plus 0. We drop 1 again and carry 1 to the next digits. 1 plus 1, 2 plus 0 plus 1, 3. We drop 1 again and carry 1 to the next digits. 1 plus 1, 2 plus 1, 3. We drop 1 and carry 1 to the next digit. And 1 added to nothing will give us 1. Now our answer is to base 2. And this is the answer to the question. And this is how we solved number to be added up in binary. If they are all in base 6, you add them the same way. But you must make sure up to 6 before you make it a round figure. Then you drop 0 and carry 1 to the next digit. That is the procedure. We look at the second example under our calculation. We have add 1,111 base 2 to 101 base 2, then 100 to base 2. And the question went further, asking us to convert the answer that we get after addition to base 10. First, let's add the figures. 1 plus 1, 2 plus 0 is still 2. How many 2s do you have here? 1. So we drop 0 and carry 1 to the next digits. 1 plus 1, 2 plus 0 is giving us 2. So what do we drop? 0. And carry 1 to the next digits. We carry 1 to the next digits. 1 plus 1, 2 plus 1, 3 plus 1, 4. In 4, how many 2s do we have? 2. So we write 0 and carry 2 to the next digits. 2 plus 1. Why are we carrying 2? We are carrying 2 because we have 2 2's in 4. And if you say take 2 2's from 4, you have 0. So you drop the 0 and carry the 2. 2 plus 1 will give us 3. And when we have 3, how many 2's do we have there? 1. Remainder 1. So drop the 1. And carry the next to the next one to the next digit. And we have 1 here to be added to nothing, and that gives us 1. Then the answer now to base 2. This is our final answer. And this answer is to be converted to base 10. That's the final process of addition. Now to convert this to base 10, as we've done in the previous lesson, very simple exercise. What do? Write the number 1, 0, 0, 0, base 2. Then start from your far right, 0, 1, 2, 3, and 4. Now multiply them out, and this gives us 1 times 2, 1 times 2 to the power of 4, plus 1 times this one times 2 to the power of 3, plus 0 times 2 to the power of 2, plus 0 times 2 to the power of 1, plus 0 times 2 to the power of 0. That's all. But if it is an objective question in year 6 and above, you are not expected to write all this, because you know once it's 0 multiplying any number, the sum is 0. So you just stop here if it's objective and quickly work out your answer. Let's quickly go to the next level. 2 to the power of 4 is not 2 times 4, but 2 times 2 times 2 times 2. And 2 times 2 is 4. 4 times 2, that's 8. 8 times 2, 16. Plus, this is, because we are multiplying it by 1, it's going to give us 16. 2 to the power of 3 means 2 times 2 times 2. And 2 times 2, 4. 4 times 2 is 8. Multiplying 1 is the same thing, 8. And this is 4 times 0, 0. This is 2 times 0, 0. This is 1 times 0, 0. Next, we add this and this, and that gives us 24. To the power of what? 10. That's all. So sometimes you can give you a question, instead of asking you to go step by step, you just add first, and then you finish the addition, you move quickly to the next step. So this is how to convert a number, not just binary. It could be basis, it could be to the power of, to the base of 6, base 7, base 8, base 9. It's the same procedure you follow to convert it to decimal, which is to the base of 10. With this, we come to the end of our first operation on binary. See you in the next class. Just follow this and use it to solve the similar questions. See you.